It's the 4.4 homework. Okay, so think about number one, if you're male or female, which is longer, your index finger, your ring finger, or they're the same length. So if I look at mine, if I put it out here, I'd say they're almost the same, but I think my index finger is just a tad bit longer than my other one. But they're pretty close. Maybe I don't know what I'd put there. Okay, but anyway, you can test yourself. Which one's bigger? I'd say they're probably equal there. So anyway, we have this data here from different people. Okay, so part A asks us, find the probability of the ring finger being longer given that they're female. Okay, so given that they're female, we're not looking at everybody, the whole group, we're only looking at the females. So we're looking at the 212 people, and there's 82 of them that have the ring finger longer. Okay. Part B says, given that the chosen student does not have a longer ring finger, so given not the ring finger, what's the probability this person is male? Okay, so I would write it like this. Probability, okay, so another way to write this is is male given not the ring finger, right? Okay, so the complement of the ring finger. Okay, so we're looking at everybody who's not the ring finger. Okay, so not the ring finger would be these two categories right here. So we're looking at these 123 people and these 95 people. So we're looking at those 18 people. Okay, so out of this group and this group, how many of them are male? So males would be 45 and 43. So 88. Okay, so 88 are male out of the 218 people that do not have the ring finger as being longer. Okay. Okay, next problem. The Titanic struck an iceberg, sunk, you know that. Some got off the ship, others died. Two-way table gives us, okay, whether they're in first, second, or third class, and whether they survived or didn't survive, okay? So part A, given that the person selected was in first class, okay, so given that they were in first class, what's the probability he or she survived? Okay, survived given that first class. Okay, so in first class, we had, if we add those people together, 197 plus 122, we had 318 people that were in first class, and those that survived were the 197 people. So 197 out of 319, almost 62% of the people in first class survived. Okay, so part B, if the person, so actually, I'm going to, before I get to part B, let's try another class. Let's try third class. At a third class, we had 476 plus 151. We had 6, this is just off to the side, survive given that they're in third class. Okay, third class was 627 people, more people in third class, and we only had 151 survive. So 151 divided by 627 gives us only 24% of the third class people survived. So the first class people definitely survived more than the other. So we might get to this later about independence, right? But knowing that what class they're in made a difference of whether they survived or not. Okay, anyway, let's go to part B. If a person selected survived, okay, so given that they survived, what's the probability that he or she was not a third class? So not third, so I'll go third complement, not third. Okay, so survived, we had these three categories, so let's think about what the total is here. So 197 plus 94 plus 151. So this would be 442 people survived. Okay, so out of those 442 people, how many of them were not in third class? Okay, that would be this category and this category. So 197 plus 94. We had 291 out of those survive. Okay, yeah, so that's part B. Question number 3. Okay, looking at those numbers, are survived and first class independent. Okay, so survived and first class. So if they're independent, survived, given that they're first class, should be the same as probability they survived. Okay, so this one up here, probability that they survived first class was 197 out of 319, which was 62. So if they were in first class, 62% of them survived. And overall, those that survived, we had 442 people out of, I gotta add these together here. Out of that many people. And that gives us 37%, okay? So they are definitely not independent. They were, knowing that somebody's first class definitely had an impact whether they survived or not. Okay, question number 4. The Health Center, National Center for Health Statistics conducted a survey of phone usage in random households in 2012. Each household was identified as having a landline telephone or not, and having a cell phone or not. L is if it's a landline, C is if they have a cell phone. The Venn diagram shows us this information. Okay, so what is the probability? So we're finding P of that a randomly selected household with a landline also has a cell phone. So given that they have a landline, that they also have a cell phone. That's what we want to find out. So given that they have a landline, they also have a cell phone. Okay, so what percent have a landline? Okay, so in our landline here, okay, look this right here. So 9% and 51% together is 60%. So 60% have a landline. And out of the landline, how many of them also have a cell phone? 51% out of the 60%. Okay. Okay, number 5, 140 characters. Okay, 2014 survey suggests that 71% of teenagers use Facebook, 33 use Twitter, and 15 both. Suppose we selected a U.S. teenager at random and learned that the student uses Facebook. Okay, so I would approach this as sort of to get it to be like number 4 a little bit. Let's do this is our Facebook only, this is our Twitter only. Okay, so 71% use Facebook, so 71% will be in there. There'd be 15 that do both though, so 15 is both. And then if 71% use Facebook, if I take the 71% and subtract the 15% there, that gives me 56% use only Facebook. And Twitter says 33%. 33% minus the 15 that use both would leave us 18% use only Twitter. Okay, so let's look at this. Suppose we take us and learn that the student uses Facebook. So we're finding the probability given that they have Facebook. We learn they have Facebook. What's the probability that the student uses Twitter? Okay, so out of the Facebook people, we have a whole group of 71%. And how many of those Facebook people also use Twitter? 15%, so 15 out of the 71. Okay, number 6, 28 students in a statistics class completed a survey. One of those was if you're right-handed or left-handed, and if you're male or female. Okay, are the events female and right-handed independent? Okay, so we need to find the probability of female given that they're right-handed. And if they're independent, that should equal the probability that somebody's a female. It shouldn't matter if they're right-handed or not right-handed. Both those probabilities should be the same. Okay, so given that female given right-handed, so right-handed people, there's 24 people that are right-handed, and females were 18 out of those 24. So 18 out of the 24 was 75%. So of the right-handed people, 75% of them are female. Okay. Now, of females overall, there were 21 females out of the 28 people. So 21 divided by 28 gives you 75%. So yes, they are independent. So in this class, it didn't matter if they were right-handed or left-handed. We still had the same probabilities. Okay. Number 7. Okay, choose a student in grades 9 to 12 at random and ask if they are studying a language other than English. Here's the distribution of the results. Okay, so 26% of them are taking Spanish, 9 French, German, and others, and then 59% of them were not taking any. Okay, what's the probability a student is studying Spanish given he or she is studying some language other than English? Okay, so we're trying to find probability they're studying Spanish given they're taking another. Okay, so we had 59% not taking a class, therefore we had 49%, 61%, no, 41% that were taking a class, right? So we're looking at that. Of the 41% that were taking a class, another language, we had 26% of those taking Spanish. So if you would divide this, we had 63%. So that's telling us that if somebody is taking another language class, 63% of those people are taking Spanish. Okay, and the very last one, I like this problem, this is a good one. So T is a person that's tall, over 6 foot. B is if they're a professional basketball player. Rank these from smallest to largest, okay? So from smallest to largest. Okay, smallest to largest probability. Okay, now, probability that somebody's tall might be kind of small, okay? So out of the whole population, if somebody's over 6 foot, it's kind of a smaller probability. The probability that somebody's a professional basketball player, even smaller than that, right? Okay, so probability somebody's a professional basketball player. Now, let's think about these two. Okay, this is saying if we're given that somebody's a professional basketball player, the probability that they're tall. If you think about all professional basketball players, they're pretty much all over 6 foot tall, not very many under. So that's going to be a very high probability. Okay. So of all professional basketball players, what's the percentage of them that are tall? Pretty high. Okay, the next one, of all the people that are tall, all the people that are over 6 foot, which I am, what percentage of them are basketball players? Okay, I think that would be going right in here. Okay, so from our lowest probability up to our highest probability. Okay, come ready to ask some questions in class.